I'm going to walk you through both ways of calculating the length of the space diagonal through a rectangular prism. So here we have a rectangular prism. Our goal is to find the length of the diagonal, which goes from one corner to the other corner, which is, yes, a space diagonal. So what we're going to do is start with the right triangle on the bottom of this prism, outlined in orange, right here. So for this right triangle, it's a right triangle. I know the length is 12, and the width of this triangle is 9. And I'm trying to find this length right here. I'm going to call that C for now. That's a face diagonal because it's on a face. So what I'm going to do is start by using the Pythagorean Theorem formula, a squared plus b squared equals c squared. I'm going to substitute 9 and 12 in for my a and my b. I get 12 squared plus 9 squared equals c squared. I'm going to evaluate my squares. 12 squared is 144, 9 squared is 81. I'm going to add together 144 and 81. I get 225. And then from here I need to take the square root of both sides. When I take the square root of both sides, I get c equals 15. So the length of this diagonal over here is 15. Now I'm going to move on to the blue triangle. The blue triangle will help me find my space diagonal length. So I have a right triangle again. I'm given this leg length is 15. That's the side we just found. And then this is just the height of the prism. The height of the prism is the 8. I'm going to label that 8. So I'm going to use the Pythagorean Theorem again, but this time use 15 and 8 for the A and the B, for the legs. My unknown this time is the hypotenuse of this right triangle, which is over here. I'm going to call that a C again. So I have a squared plus b squared equals c squared. I'm substituting in 8 and 15 for the A and the B. So I get 15 squared plus 8 squared equals c squared. Evaluate the squares. 15 squared and 8 squared. You get 225 and 64. Add them together. You get 289. At this point, we're ready to take the square root of both sides. So we're going to take the square root of both sides. The square root of 289 is 17, and the square root of c squared is c. So the length of the space diagonal is 17. So that's one way to get the length of the space diagonal. It would involve using the Pythagorean Theorem twice. Once to get that face diagonal, and then the second time you're going to use that face diagonal and the height to give you the length of the space diagonal. The other way you could use is using the formula. The formula is the diagonal length is equal to the square root of the length squared plus the width squared plus the height squared. So what I'm going to do is plug in the length, width, and height of my prism, so the 12, the 8, and the 9, into my formula, and I get the following. I have the diagonal length is equal to 12 squared plus 9 squared plus 8 squared. So now I have to evaluate those squares. 12 squared is 144, 9 squared is 81, and 8 squared is 64. Now I'm going to add those three numbers together. And when I add them, I have 289. So from here, the square root of 289 is 17. So if you note, there's two different ways to get the length of this space diagonal. Both ways gave me an answer of 17, so I just figured out no matter which method I choose to use, the length of this space diagonal is equal to 17.